Hello, and welcome to this OpenTopography tutorial. My name is Chelsea Scott, and today I'll be showing you how to use OpenTopography to process vertical topographic differencing for Port Washington, which is along the Lake Michigan coastline in Wisconsin. And this video was originally designed to be part of an undergraduate curriculum activity, which will be linked in the description below. However, this video is applicable for anyone interested in using OpenTopography to conduct topographic differencing. So the first thing that you want to do is go to opentopography.org in any internet browser. The next thing you'll want to do is come to Data. So again, that's right here on the upper right side. And you'll want to click Data at the top. Now, before we look for our area of interest, for this example, you do need to sign in. And if you haven't yet created an account, you'll need to do create an account. And in today's example, we'll be looking at processing NOAA datasets, and these are available for free through OpenTopography to those with an EDU account. These NOAA datasets are available through OpenTopography to other academics through an application process, or more broadly through a OpenTopography Plus subscription, which you can access here. So again, if you don't have an account, you'll want to say create new account and be sure to log in. So here we are looking at the data sets available from OpenTopography in the US. The data sets are colored by the type of data with the legend shown here on the right. So data sets in red are data sets that are formally hosted by OpenTopography, and these data sets are completely open to all users. The USGS 3D Elevation Project and NOAA datasets are available to US academics for free, international academics via an application process, and then others via an OpenTopography Plus subscription. Community data space are relatively small data sets, of which there are some here along the Lake Michigan shoreline. These are open to all. And then we have global and regional DEMs, which are data sets that cover near global areas, specifically looking at the whole US. So for today's example, we'll be looking at Port Washington. So you can either navigate to this area if you know where it is exactly, or you can come here on the left, and then you want to press this button here where it says zoom to location by placement or coordinates. So we'll click there. And first you want to enter the country. We're interested in the United States, so we'll leave that as the default option. And then below, you'll want to type in Port Washington. And we're looking at Port Washington, Wisconsin, so we'll select that. And then OpenTopography automatically scrolls us down to see the available data sets. And for this area, we have all types of data available. And we're interested in this example for topographic differencing, which is going to be these NOAA data sets. So you want to click NOAA, and then to make this to see fewer things, let's turn off the other data sets. Now, so we have topographic differencing now implemented within any of these data types, but not across them. So you can difference any NOAA dataset with a different NOAA dataset. So let's come down here. We're just actually turn off the NOAA datasets to see them a little bit more clearly. And you can change the view here. You can see terrain is the default. Hillshade is a different option. And then you can also select satellite. So let's come here and see the NOAA data sets again. So we'll put in the box over our area of interest. And we still have 5 NOAA data sets in that location. And we're going to difference, or we have 1 data set for the differencing being the 2020 data. So we'll see this one at the bottom, and then to start doing differencing, we're going to click this differencing tool button. So here we are, we're at NOAA vertical differencing, and we're looking at the 2020 data set. Scroll down, and then we have the option of selecting data sets that we want to do with differencing. And the data sets in our area of interest are going to be shown in that dark color. The ones that overlap our data set but are not in the area of interest are in gray. And for today's example, we'll be looking at differencing this 2012 data set. Note, if you pick a longer time span, you are likely to see more change because of the longer time span, but the older data sets are also likely to be more noisy and or have a lower point resolution. So we'll be looking at differencing the 2012 data. And we can adjust the area of interest using this select a region. So we'll look here. And then we can see here, we have these 2 data sets. We have our reference, which is the later, which is the 2020, and the compare, which is the 2012 data. Our area of interest contains approximately 11 million points, which OpenTopography will be able to process quite quickly. You can choose to do this differencing with ground only, which will process considerably faster and will remove the effect of vegetation. So let's do that. And then we'll scroll down. You can just keep these options selected. We do have several error tools which you can look at and explore. However, we will not be looking at those today. And then you do want to enter your email address. So then once everything is ready to go, you can press submit. And right now, these data sets are being processed at the San Diego Supercomputer Center. And when the processing is done, you will see this page which will display the results. You're also welcome to close the window, and then you will be emailed a link to process or to the processed job results. All right, so that finished processing in 82 seconds. And then you have the option of downloading the differencing results here by downloading this tar.gz file, which we'll do shortly. And you can also see the differencing results here. So this is a map showing topographic change, where red indicates downward motion of the Earth's surface. So this could be subsidence or landslide. And then blue is an increase in the elevation of Earth's surface, for example, from deposition, from the landslide, for example, from rivers, or other processes such as the building of a new house. And so to zoom in, we can say view on map. That will then open this window and can zoom in and look at these processes in more detail. So again, here are our differencing results. We also can see the reference, which is going to be the later data set, so the 2012, and then the compare, which is the earlier one, so the 2013 to 2012. So you can look here and we see that there are some changes in the shape of the bluffs between these 8 or so years. We do see that the bluffs have generally retreated towards the coast, and then we can again look at the differencing, where we see red is we're going to expect that coastal retreat to have occurred. So we can again look there, so that area is red. So you would expect some big change, for example, the retreat of the bluffs in that area. And then we also have this slider, which lets you use a slider tool to compare the topographic hillshades from 2012 to 2020. So to use it, you'll want to move the slider. And again, this lets you see the difference in what the landscape looked like between those two times. And so this is a very easy way to explore that that topographic change and the bluff retreat. And now we can go back up to the top, and you may want to explore the differencing products in more detail. So to do that, you can download this vertical differencing file. So then we'll look at it in QGIS. So if you go to downloads, and then we have the vertical differencing file. So, and then here we have three different files. We have output.compare.tiff, and this is the DEM, or I guess the DTM, since we're using ground points only, of the earlier data set. So that's the 2012. And then we have the reference, DEM, or I guess DTM still, and that's for the 2020 data set. And then the vertical differencing. So we can pull all of these three into QGIS. And so here we have these data sets, and we can very quickly make the DTMs into a hillshade. So to do that, we'll double click, and then we'll go to symbology, and we'll say hillshade. I recall in a different OpenTopography video, I explained that this is a very quick way to make a hillshade, but will likely result in artifacts. So there is our hillshade. And these grid artifacts that you see is what happened when we made the hillshade via the symbology. The other option we can do is to go to raster analysis hillshade. Again, that's raster analysis hillshade. And we can input these files. So again, I want to make sure our input layer is the output compare. And then can come down here, hillshade. You can save to a temporary file, which is what we'll do today. And it is fast, but the file is not saved. So if you want to come back, you'd have to make it again. We'll say run. That finished in real time right there. And so here we have the topographic hillshade from the compare dataset. And then we can also look at the vertical differencing. And let's change the color scale. So we'll click on that vertical differencing label, go to symbology, single band to single band pseudo color. And then here is the color bar that it suggests we use. And if you don't see this one, you can find it here in the red to gray. And you could keep that, or if you want to more mimic what we have in OpenTopography, you can just change these colors, again, to be red, white to blue. And say OK. And then you want to change the min and max. It's up to you exactly what the values are, but I do suggest that it's symmetric around 0. So for example, you could have -5 to 5. And we'll say OK. So here are the topographic differencing results, where red is going to indicate that loss of material or lowering of the elevation of the Earth's surface. And then we can see, for example, where there is quite prominent change along the hill slope, for example, right here. You can zoom in a little bit more. and then compare what the, actually, we'll remake the reference better. So our reference hillshade is the top one, and then the compare is the bottom. You can rename them to make that more clear. Say rename layer, rename layer to hill reference. We can do that here. And so we can compare. And then in QGIS is the top layer that is selected, that what you will be seeing. So here's the compare. And we can turn on the reference. We do see that retreat of the bluff, which is then reflected in the red colors of the topographic differencing. And this concludes our video. Thank you for watching OpenTopography's material on topographic differencing.